definitions, and for this one we have one definition. So f prime of x is the limit with a difference quotient. That's only one. This is the formal definition of the derivative function. The answer is not a value, it's a function. And the function that we determine as f prime will give the slope of the tangent line at any point where the function has a derivative, of course, because we're going to talk about it in a minute. A function is not always differentiable. So let's start with that, and then we'll play with this definition. When a function does not have a derivative, we like to say it is not, instead of saying does not have a derivative, we say it is not differentiable. When a function does not have a derivative. The same thing with when it's not differentiable. And here are the situations. One more. So let's analyze these situations. Okay. Here's the first one, not continuous. If a function is not continuous at a point, it cannot be differentiable at that point. That's situation number one. Not differentiable. It's differentiable everywhere else, but it's not differentiable at this point. Why? It has two tangents. One tangent here and another tangent here. If a function has two tangents, that limit, this limit, does not exist. So the derivative is a limit. So from the right-hand side is this number, from the left-hand side is this number. They are not the same. Function has to have one tangent in order to be differentiable at that point. This is normally called a cusp, like between two teeth, and the tangent is kind of vertical. So vertical tangent, not differentiable. Again, the situation with two tangents. This is called the corner, not differentiable. And this is another situation with a vertical tangent. What does this mean? This is an infinity. So if the limit is infinity, the derivative doesn't exist. If this limit does not exist everywhere, and it's infinity, then so infinite tangent. Better, I would like to say vertical. That's better than, you know what I mean. The limit is infinity, but I prefer writing vertical tangent. So these are the situations when a function is not differentiable. One very important aspect here is continuity implies differentiability, or the other way around, or both. So if a function is continuous everywhere, is it differentiable everywhere? If a function is differentiable everywhere, is it continuous everywhere? Which of these two arrows is valid, or both valid?
It's differential if it's continuous, but it's not continuous if it's differentiable.
So, if the function is differentiable, it will always be continuous.
Yeah, that's what I mean.
Okay, so if the function is differentiable, it will always be continuous. This is not true. Look how many, I showed you 3 different continuous functions, but they're not differentiable. So a function that is continuous is not automatically differentiable. But a function that I tell you, or we are told, it's differentiable everywhere, it must be continuous everywhere. Guaranteed, because if it's not continuous, it will not be differentiable. So a differentiable function will always be continuous. That is true. But if a function is continuous, it's not guaranteed to be differentiable. I would like us to apply the definition a couple of times or just once. It's up to you. I'll let you choose the function right this moment, just to try to get to those. Okay, choose any function you want. We use the radical. Maybe we want to look at another rational if you want to. We already worked on quadratic and cubic already, so maybe rational. We worked on radicals. So I think.
Bring it close to the camera?
Yes, of course.
Sorry. Can we do 29?
29 it is. Very good. Good pick. So let's look at 29. So we're asked to find f prime of x, and they're giving us f of x as u. Oh, I'm going to change it to x. As x plus 1 over 4x minus 1. Okay. There is only one definition for f prime of x, which is the limit as age approaches 0 from x plus age plus 1 over 4x plus 4h minus 1 minus x plus 1 over 4x minus 1 divided by h. We started doing problems similar to this without these two from the first day of classes. We didn't put this till today, and we put that a second time we met. So my first step is to find what? Yes, if I plug in, it has to be 0 over 0. No discussion there. What do I have to find first? The
least common denominator.
Excellent. And what is it?
Minus 1, parentheses, 4x plus 4h minus 1.
Thank you very much. Which means that this top has to be multiplied by what it does not have in the denominator. And this top, I'm going to write it here because I don't have enough room, has to be multiplied by 4x plus 4h minus 1. In these problems, please watch me run out of room. I always do. My apologies. Get ready for that. So I distribute 4x to these two. 4x squared plus 4xh plus 4x. I distribute negative 1. Negative x minus h minus 1. Of course, I'm not going to have enough room, as you see. Okay, so x times 4x with minus in front. Negative 4x squared. x times 4h with minus in front, negative 4xh. X times negative 1 with minus, so this is plus x. Negative 1 times 4x, I'm going to continue here. Minus 4x, minus 4h, and plus 1. So we are determining the limit of the difference quotient. What has to happen first? If it doesn't happen, I have to go back to the drawing board. I know I have an error somewhere.
Stuff with no H's disappear.
Yes, great job. If you remember that, you're always going to be happy because you will always check your work. So I'm crossing out the 4x squared with a negative 4x squared. Here's a bonus. I take it. I'll take it. 4x, negative 4xh with positive 4xh. Wasn't supposed to, but I'm happy. The positive 1 with negative 1. The positive x with a negative x. The negative 4x with a positive 4x. And all this jumbo here, mumbo jumbo if you want, I have left a negative h and a negative 4h. There is nothing else left, as expected. All terms without h went away. So the numerator now is negative 5h. So limit, as h approaches 0, I write negative 5h over this whole thing, 4x minus 1, 4x plus 4h minus 1, and I already flipped this, multiplied by 1 over h. That's why I had it prepped as h over 1. So that this is the second thing that has to happen for every function when I determine the difference quotient or the limit of the difference quotient. It doesn't matter. It has to follow the same rules. Now and only now, I drop the limit operator. And only now, at the very end. And now I can state what the answer is. And that is a function. And it's the function that gives the rate of change, the instantaneous velocity, the slope of the tangent, all of the above. Everywhere where the function is, I need to hear the word. Anywhere where the function is, d what?
Differentiable.
Thank you. Exactly right. So the final answer would be, the top goes to
Negative 5.
Great job. The denominator, remember it's a function. The denominator goes to give it a shot.
Would it be 16x squared minus 1? I mean plus 1.
First of all, a minus b squared has 3 terms. That's one common. Secondly, never multiply. It's not wrong, but we never multiply the factors in the denominator. One more try. Don't be shy. Anyone?
Would it be 4x minus 1 squared?
Excellent job. This is it. Great job. This is f prime of x.
How did she get 4x minus 1 squared?
H approaches 0, so this is 0. 4x minus 1 times 4x minus 1. So where is this function undefined? That's where the original function does not have a derivative. Correct. Very good. I have just one more thing that I'd like to show. Everything else is done. I just want us to graph a derivative. Just for you to have an idea. So we're given a function. We already graphed the derivative with the velocity, but I'd like to choose one more, and then we'll start our quiz.
Can we do D?
This one. Yes?
Yeah.
Okay, perfect. So let's copy D. So this is problem 3 in 2.8. And I'm going to copy. Make sure that you have room underneath. If you're at the bottom of the page, move on to the next page, please. You'll see in a minute why. Like we did with the velocity, I have to have one graph under the other. Complete continuation of the y-axis. So they have to be identical. Okay. So I'm copying, to the best of my knowledge, my abilities here, I would say D. So it appears to be symmetric with a minimum here and 2 max. Okay, so I'm going to try to make it as symmetric as possible. I can never make it perfectly symmetric, sorry about that. So this is function f, and we want to come up with a best approximation of f prime. It will be a rough estimate of the graph of f prime, of course. Okay, so I will analyze the graph of the function a little bit and create tangents, as many as I can, or as many as I would like to. Okay, so here it appears that this is the tangent. Here appears to be this. Here it appears to be 0. You don't have to draw this. I need to make sure that I hit the exact point. Here the tangent, it appears to be 0 again. So I did find 2 points already for the derivative. Of course, also here. So the derivative has to go through this point, and through this point. Why? Because the function has a slope of 0 in 3 different points. Then here from this point to this point, to the origin, the function appears to decrease. When the function is decreasing, so when the function is increasing, the slope is positive. Slope is positive. Then when the function is decreasing, the slope is negative. When the function is increasing, the slope is positive. When the function is decreasing, the slope is negative. So coming from a huge, as big as possible, positive value, smaller and smaller getting to 0. So this appears to be the first piece. The slope is positive, and it increases, the function increases, but the rate of change, although it's huge here at this point, here it's smaller, and here it gets to 0. Okay, one other thing I should have mentioned, there are no corners, no cusps, there are no vertical tangents, so this function is a polynomial function. It will have a derivative everywhere. So you did not choose, I should have mentioned, you did not choose one with corners and cusps. So this function is polynomial, its derivative will exist everywhere. Good, so now the derivative is negative. At a particular point, it's kind of max negative. So somewhere here, max negative. I don't know, maybe here. I have to find the triangle and say -2, -3, whatever. Instead, I'm going to say this is the maximum negative point for the derivative. So it will decrease. It will be negative. It decreases to a possible maximum for it. But then it comes back being still negative, but it comes back to 0. Okay, fine. So this piece has this derivative. If you want to determine the slope of the tangent line everywhere, just look here and determine the value, and that's the slope of the tangent. On the other side, the function is increasing. If the function is increasing, then the derivative is positive. At least somewhere it reaches a maximum. It has to be symmetric, so I'm going to make it as symmetric as possible. It crosses at 0 right here, where the derivative is 0, and then all the way to negative values. So it makes sense. It appears to be a function that has degree 4, and of course when I differentiate, you will see it will be a function with degree 3. It may be 6 and 5, whatever, but it makes sense that this is the derivative. So it has to be a smooth continuous function because this is polynomial, so something like this. Then I can make some adjustments and make it nice smooth function. So that's how we create a rough graph of the derivative.
I
Okay,
have a question.
please.